Good afternoon, everyone. How's everybody doing this afternoon? Well, as you heard this morning, you learned a lot about serverless applications, the benefits and capabilities you have with Lambda, with API Gateway, and how you can scale and not worry about servers. So this afternoon, we're going to take it to the next level, and we're going to talk about how you can get these types of patterns and applications directly into production for your companies and your systems. Quick bit about me. My name is Justin Pirtle. I'm a principal solutions architect here at AWS. I focus now on serverless technologies. But previously, I supported customers across Texas and Utah and the Pacific Northwest for the last few years. And before that, I've been in several engineering teams at Amazon and Microsoft. So how can we continue what we started this morning? You've learned about what API Gateway, Lambda, Cognito, all of these various services are, right? So now we're really talking about best practices for how you can get started quickly and take these all the way to production. First, just to recap, for a Lambda function, right? A Lambda function is fundamentally an event source. So in this case, like your lab that you were doing earlier, a particular request to an API endpoint that then goes to your function, which is your code, right? Your choice of runtime. So in these labs, you're using particular languages, but as you can see, we support not only Node, Python, Go, Java, C#, but now, as of last November, the ability to bring your own runtime. So we have runtimes now that customers and partners have built in PHP, COBOL, Rust, Erlang, and more. And even more will come. And then fundamentally, from your code, you have the ability to interact with third-party services and AWS services to transform and to manipulate your data. So as you heard this morning, a Lambda function has fundamentally three parts. You have your code, and inside your code, you have a handler function. So every time Lambda is invoked, you go and enter this handler function. And then when you enter that handler function, you have an event object and a context object. And the event object is the data, right? It's all about your data, your payload, your request, your change in your resources. The context object, however, is context about that request. Where did it come from? What's the log group? What's the runtime ID? All these kind of things. And you can hook off those and use that in your code as well. So when you look at this, one thing to realize, even though we call it serverless, in fact, there are servers behind the scenes, right? The key value here is you don't have to manage any instances. You don't have to think about servers. It scales as you need. And you never pay for idle. And that's the key benefit, right, of serverless. So what really happens when you invoke a Lambda function? Where are the servers? Where is the magic, right? What happens there, and it's important to kind of know a little bit behind the scenes because it can help you architect to optimize your workloads for this, is what we do is we look at your request, and we see for the function that you've requested, do we have an existing worker that already has this code on it? And if we don't, what we do is we allocate a worker to you in your account. We spin up a sandbox for your function, much like you could think of a container. That sandbox has your application runtime of choice, so Java or Ruby or Go. It pulls your code into the sandbox. Right? If you've attached to the network with a VPC integration, we even attach a network interface. And then we finally enter your handler after we've initialized the runtime. And before we enter your handler, we actually run anything else in your code that's not part of the handler, that's outside of the handler, that's global in scope. And so this is important to know because all of the things I just said, that's what we collectively call a cold start with Lambda. But what happens is when your function finishes and we leave your handler, we don't immediately throw away that sandbox. We actually leave it around for a period of time where if you have another invocation of the same function come, then we're able to reuse the same execution environment. And this allows you to take advantage of that to optimize your code to work especially well and be highly performant in Lambda. So to break this down a little bit more tactically, this is pseudocode of sorts. So you have a handler at the top. But the goal of the handler is to not have much code in it. It's really about a lightweight wrapper to invoke particular helper functions, your business logic, whatever it may be. And ultimately, as you have more code and complexity, you're going to break out different functions and business logic, right? But at the same time, as I mentioned, because you have the ability to reuse that container environment, things that don't have to be run upon every single invocation, things that you could do just once for the whole environment, say connect to a database or get a secret API key from secure storage, something like that that you could do once, hold in memory, keep open that connection. You can leverage that to make your functions perform faster upon their secondary and further invocations. And so things like that, where you're configuring dependencies, configuring database connections, opening these kind of things, all of that we call kind of helper functions. And those things are also good to keep outside of the handler, because yet again, you have the ability to take advantage of container reuse. So now that you kind of understand that, we saw earlier today with the API gateway deployment, and we had a single method, single resource. What might this look like for a production API? Ultimately, each of those methods needs to respond and interact with some sort of persistence store, right? A database, something like that. And you probably also need to interact with keys and secrets for encryption, and maybe configuration values. We have a service called parameter store you heard about earlier. So because of that, what happens is, as a best practice, you don't want to have a single function be a monolithic code base, just like you could have on-prem, or you may have today. Instead, we recommend you have a function per method in your API in your environment. And so what that could look like is each of those functions all of a sudden may have the same helper functions, the same business logic functions, the same code dependencies and modules. And then all of those are talking to the same databases, right? So you have all this stuff to manage all of a sudden. Well, as you can imagine, the amount of moving parts can quickly grow and increase. And so the goal here is for you to not have that complexity to take on yourself. And so because of that, we have a variety of frameworks that are out there. And particularly the one that we advocate is something called SAM. So if you haven't seen SAM before, SAM is both our mascot and the name of the actual framework. It stands for Serverless Application Model, but SAM is also a squirrel. And so this is Sam the squirrel. He's our serverless mascot for AWS. And so with Serverless Application Model, you can think of this as a CloudFormation extension or a CloudFormation transformation layer. By show of hands, how many of you worked with CloudFormation in the past? OK, a handful of you guys. OK. And probably some of you were clicking the launch template button earlier in the lab, right? So you were using it then. What about SAM itself? Have any of you used SAM before? OK. So I'll assume this is pretty new. So if you've worked with CloudFormation, and if you've written a template by hand, what you'll know is that CloudFormation has a variety of things: parameters, inputs, resources, all of this. You can define those templates in JSON or YAML. And ultimately, they can get quite verbose, because you're defining all of these resources. You're defining all of these attributes and values. And so what SAM is sort of like CloudFormation shorthand. It's literally a transformation layer on top where serverless resources like functions, API gateway deployments, tables for DynamoDB, these kind of things, you can define very succinctly. And we expand it out at runtime into CloudFormation at the deployment time of your templates. So just to show you an example, this is what, about 15 lines of code, maybe up to 20. So this is a SAM template on the left. And if you look at the top, the reason you know it's a SAM template is because you see there's a template version, the template format version. So that's always there for CloudFormation. But there's this special line that says transform. And this says AWS Serverless, and that's our API version. That means this is a SAM template. So when CloudFormation gets it, the first step before it actually tries to deploy things is to transform this into CloudFormation syntax. And then within there, you can see that this is creating a function. So we have type serverless function, right? And we have a particular set of code and a handler and all the things that you need to define, as well as a table at the bottom. So with just one line of actual templating code here in the title, the logical resource name, so 2 lines, that will expand to be a full Dynamo table with 5 read and write units of capacity, and you don't have to write all the other semantics of that. So when you look at that 15 lines actually becomes dozens of lines of code of CloudFormation behind the scenes, and becomes all of the things you see on the right, all of the different objects: Lambda functions, permissions, API gateway, CloudWatch, and more. And so what SAM offers, anything you have in CloudFormation that you already are doing in CloudFormation, you can just pick up and drop into a SAM template. It'll work just fine. But what SAM gives you as well is the ability to have 5 special types of resources that you don't have to do that same heavy lifting. So functions, APIs, tables, and what we'll talk about is a serverless application, along with Lambda layers. So all 5 of these. And then in addition to that, when you define a function, as we said, a function is only useful with an event source. So we actually support 50 different types of event sources with Lambda today. All of them, all you have to do is put in here events. Say this is an S3 event in this case. Any notification, any change event on the My Photo bucket would trigger this Lambda function. So a popular Lambda use case might be image conversion, right? Resizing, these kind of things. And at the same time, though, when you have a lot of functions, a lot of the parameters and attributes of those are identical. So SAM has this concept called globals, which means most likely you're writing the application for a single microservice in the same language. This allows you to pull that runtime attribute up to the top. Your code, for whatever code is reused, the same zip file may support multiple functions, pulled up to the top. Memory allocation, timeout, whatever you want to pull up there, many of those attributes can go into globals, and it makes it even shorter for you as you define multiple functions down below. Now, as we learned earlier today, Lambda has a permissions model that includes 2 pieces. You have both the invocation or function policy, which is what can invoke the Lambda function. And then you have the execution policy, which means once invoked, what can the function actually do, right? What can it talk to? Could it talk to a database? Could it talk to S3? These kind of things. And so what we have here, to also make life easier, is we have the notion of policy templates. And so we have over 45 different policy templates that you can just drop in with a single line, like this is an SQS polar policy. So by having this in the name of your queue, all of a sudden now your Lambda function can be reading your message queue, processing all of those events as they come in, and you automatically have that integration set up, as well as the permissions to read the queue, and to actually call back to the queue to say we finished processing the message. So there's 45 different policies that are out there above and beyond what CloudFormation offers for easy drop-in, and you can look them up in the SAM repo at this link. Now, in addition, we've got all these functions. We've got a way now to deploy them, but we also need a way to configure them. Right? You need a way for them to know what tables are we talking to, what secrets do we need access to, what environments are they for, all this configuration value. So you have a few ways to do this. One is you have environmental variables. So much like your laptops or any OS environment you've been in, you can set environmental variables. You can read those directly within your sandbox environment. And you can even optionally encrypt them as ciphertext, where you'd have to, at runtime, use our KMS service, our key management service, to decrypt those. So that's certainly an option for you. It's particularly useful for things like keeping track of, is this a dev environment function, a test function, a prod function, something like that. But what the problem with this is say you define this across all these functions, and then all of a sudden you need to go update a value. Maybe it was, say, the database password, for example. Even if you made it ciphertext, now you need to go make a call on every single function to go update this password so all of them can get the latest password. Well, because of that, we have something we'll talk about called parameter store, which is coming up. And that allows you to basically centralize your parameters, even your secrets, with another feature of it called Secrets Manager that integrates with it into one place. And you can pull that at runtime or at your execution. But for other configuration flexibility, we offer something called stage variables. And so this is a way, with an API gateway, I don't know if you noticed, but every time you have a deployment, you always have a stage. So the common names for this, most commonly, are dev, test, prod, these kind of things, right? Stages, or as we call them. And these actually can be used as variables. So you can actually pass in, say, prod is maybe the stage variable name, and all of your functions that are prod functions may end in prod, right? So you can actually use that to make sure you're pointing to the right functions. Or maybe you have different function names for your authorizers. You do different authorization and authentication in prod than you do in dev, and you want to point to that particular type of authorizer. You have the stage variables to go there. At the same time, though, you also have a feature in Lambda called Lambda versions. But first, let's look at this just to see how this takes place. So this is a SAM template. Just like a CloudFormation template, it has parameters at the top. So the parameters here we're defining is we've got an environment. Every time we deploy it, we're going to say if this is dev or prod. And then within that, this particular Lambda environment, we want to have the concept of feature toggles. So in prod, certain things will be turned on, and in dev, other features will be turned on. And so in CloudFormation, you have this notion of what's called a map. And you can see here special feature 1. And then what we do is within the map, we have each of the basically key values to key off of. So in this case, our environment names. And then we have actual values we want to pull out of it. So in this particular case, what that allows us to do with one template is reference. If you see these little exclamation sign ref, exclamation find, and map, these are called intrinsic functions. And these are a capability of CloudFormation that allow you to basically read values from across the template to have things dynamically reference each other. So all you'd ever have to do to deploy this is just literally type in, pick between testing stage or prod. Those are your allowed values, and everything else would just automatically happen. So in this case, what's happening is if I put in testing, for instance, or staging, automatically my environmental variables over here for spec feature 1, it's going to look in the map. It's going to see for testing and staging, I'm going to turn on this beta feature. But in prod, if I deploy it, it's not going to be on. The environmental variable won't be set for that. And you can see the environmental variables are just there in line right in the template. At the same time, those variables can also be passed in. It was a parameter at the top. It can be passed into API Gateway as a stage variable. So I mentioned parameter store. So parameter store is a way to centralize your configuration. And just so you know, this is available not just for serverless. You could use this for anything in AWS. So containers, EC2 instances, whatever it may be. And this allows you to define parameters, and it's a very simple API. It's put parameter, get parameter. That's it. But you also have the optional ability if you want, if it's a secure string, like a password, API key, something like that. You have the ability to basically store it as ciphertext and encrypt it even when you pull it out of parameter store as ciphertext. And then to have actually an API helper with KMS, where you would have to have the credentials to the key management service key to decrypt that secret. So for a database password or something secure, you'd want to enable that encryption feature. But as you can see on the right, all we have to do to use this in code is just and define the method here, which is get parameters. And in this case, we're saying I want to actually get the Lambda secure string parameter. It happens to be encrypted, so we're going to say with decryption equals true, which just means give it to me in plain text. And we're going to decrypt it locally in that environment. And so with this, the nice thing, it's controlled with IAM policies. So you can make it where certain environments can get to certain parameters, certain ones can't. It's all recorded in CloudTrail and integrates with all of our standard APIs and SDKs. And then to put this together, so I mentioned Lambda functions have what we call aliases, and we have versions. So Lambda functions, by default, if you actually use this feature, every time you deploy new code or new configuration change, or even an environmental variable, all of that together is a version. So what can happen is you can have, in this case, we have 8 versions. And we also have aliases that we're pointing for Lambda to different versions. So if we're using the same account, you could actually have prod and dev point to the same Lambda function, but actually run different code, just because prod, in this case, is on version 3 and dev is on version 8. Now, you can also, this is what we would call a single stack environment, right, where everything is in one account. You can also do multi-stack environments and still make use of these features. But that's what this is. And then the nice thing is the stage variables from API Gateway can be pointed to the aliases of Lambda, so you can map prod to prod, beta to beta, et cetera, right, for those. And one of the reasons this is very helpful, even if you are using different accounts, where you have dev, test, prod, all different accounts, is we have a feature called traffic shifting. So like any production system, you want to roll out new changes, but you also want to make sure you're not undermining the stability of your users and your customers. And so what traffic shifting is the way that through our a free service integration we have with Code Deploy, what happens is actually we have the ability to point API gateway, and particularly it's with the Lambda aliasing, to weight the aliasing where you can control the traffic flow. So in this case, when we start a deployment, we're going to say send 5% of our traffic, in this example, to version 6. And we're going to say give it 10 minutes with 5% of the traffic. And if it doesn't throw any alarms or any errors, then we'll go ahead and potentially do the next 10%, or maybe we just do the rest 95%. It's up to you. We have the options there. So if you just do basically one small percentage and then flip everything else over, that's what we call a canary deployment. Or if you want to do 10%, then 20%, then 30%, progressively, then we call that a linear deployment. It's your choice. And it's free. It's built into SAM, too. So you can see here with SAM, this is an example of a particular environment where we're auto-publishing an alias of the environment name. So all you have to do is add that property. And then you have to add deployment preference. And here we're saying, well, every 10 minutes, we want to shift over 10% more of the traffic. So within 100 minutes, we're fully shifted over in prod. But at the same time, how do we know when we might want to revert? Well, the nice thing, because those Lambda functions and the versions I mentioned are immutable, shifting back is as simple as pointing the alias immediately back to where it was. There's no need to redeploy. It's an immediate rollback. But we need a hook to know if we need to roll back. And that's what the alarms are here. So the alarms are just saying if this alarm is greater than 0, it can be any CloudWatch alarm you want. And it can be up to 10. You can actually just roll back when the alarms are breached. And then finally, you have the ability to do sort of sanity tests, integration tests with pre-traffic hooks and post-traffic hooks. So effectively, we deploy the new Lambda code. We'd run the pre-traffic hook, see if the code is behaving as we'd expect. And if it is, then we go ahead and do the canary deployment. Then we do everything and roll it all over. And then we do a final post-traffic check. And then we go ahead, and after all that's done, then we actually stop using the older version. So that's safe deployments. So just to show you, I mentioned there's canary versions and there's linear versions. So you have all that available here. Auto-publish alias just simply means that SAM will take care of all this for you in conjunction with code deploy. You don't have to worry about it. And of course, we have all at once as well. Though if you're doing all at once, I don't know if I'd bother to add this into the template. Kind of already mentioned this. This is the before traffic and allow after traffic, right? So the hook's there for you for safe deployments. And then let's just actually make this a little bit more real and look at SAM more closely. So I want to take you in. I know this morning you already had a chance to learn some about SAM, but I really can't emphasize enough the importance of thinking about your deployment strategy early on. And so I want to take you here. If you haven't already this morning, you will certainly see this afternoon in our next workshop, our Cloud9 environment. And so Cloud9 is basically an interactive cloud-based IDE. You can run it. There's no charge to run it in your account. It just runs on an EC2 instance, or you can even run it over SSH with a desktop in your home for free. But for those of you that have Chromebooks and everything else and have always wanted a cloud-based IDE, now you've got something that can do almost any language you want. So to show you here with Cloud9, I have a variety of things here off to the right, but what I want to show you is particularly the SAM CLI. So just to show you how quickly it is to get a boilerplate project running, let me actually just go and refresh my environment to pull it up here. And we'll start with just the assumption you're just doing a brand new project, right? A boilerplate. You want to get going quickly. So what I can do here is I can basically say SAM, and in case you didn't know, once you install the SAM CLI, you can always, at any point, just say SAM help. And you can see there's only a handful of commands. Actually, I'll pull this up here first so you can see. So for today's purposes, we'll go ahead and use something called SAM init, which is initialize a sample application. So we'll say SAM init, and we'll say help. And you can see here, all we have to provide that's mandatory is the runtime. And so I'll say this is going to be a Node.js, let's say 8.10 application. And I'll say this is going to be demo app. It's the name of my app. OK? Well, it's gone ahead and generated not only a SAM template that already has a lot of things out of the box, but it's generated a nice framework and folder structure for my functions. So let me go over here, and you can see on the left what we've created. So demo app, by default, here's our SAM template. So if we go look at it, we can see it has a transform, serverless, AWS serverless, right? Description. Our global section for all of our global config. We have a single function right now. It's called hello world. And we have an API invocation source. So this means by just having this simple bit right here, that's all it takes, and it'll know to configure API gateway integrated with our Lambda function. And so in this case, I'm going to take off hello as the path, because we'll just have a single get. And then we have our outputs. So what's nice here, for those of you that have been looking at this today and thinking, well, how can I do all my traditional things that I do as a developer, like run my unit tests, do local testing, right? Not have to push to Lambda, wait for logs to show up eventually. How can I make this quick? Well, what's neat is with SAM CLI, we actually have the Lambda runtime that's been Dockerized. So a Lambda-compatible Docker environment is out there. So it allows you to actually run the API locally and live reload your changes, assuming it's an interpreted language. So if I just do SAM local start API here, let me go in the right folder. Then you can see this is already running on port 3000. So just to show you what's going on here, and I haven't done anything yet, it's just boilerplate code. I can go curl here, and I can see hello world came back, right? And if I go into my function, you can see I have a package JSON, as like any Node.js app, and I have app.js. And this is just the default, boilerplate kind of handler here that just sends a 200 response that says hello world. But all it takes to even just start to get some dynamic interactions here, I can even, out of the box, this will pull your IP address of the sandbox and return that. And so just making these quick changes. If I go ahead and run curl again, let's see what's going on. Oh, I haven't installed my dependencies. So that brings us to another thing we need to do. But first, to actually show you this. So in this particular case, I'm using a library here called Axios. It has an npm package, and it wasn't installed, right? So there's nothing that could actually resolve that. But now I've resolved my dependencies. And what's great about SAM is you actually don't have to do anything each time. So if you look now, it went ahead and ran. Oh, and I have something commented out. Where am I missing the declaration? Oh, here. So now, in terms of quick debugging experience, there you go, right? I didn't have to go stop and start processes, live reload, full emulation of the API. There are some exceptions, like authorizers and things like that. This won't emulate the authorizers today. But you can see now I've got hello world back, and I have the IP address of the sandbox coming in as well. So that's a look at a simple basic project. Let's look at one that shows you a little bit more of what we talked about. So speaking of configuration. So first, let me go in here just to show you how to get to this. If you go to Systems Manager, this service, I think, is commonly overlooked. It's an entirely free service, on-prem or in the cloud, serverless or instance-based. And one of the features of it, it has many features, but one of them is parameter store. And so you can see here I have a variety of parameters I've defined so far. Let me go back. And here, in particular, if you notice, I have in this environment, this is a dev environment. So I've actually named things /environment/dev. And that's strategic because I can actually restrict permissions based on the string. And so I can actually say certain paths this thing could get to, certain paths that thing could get to. So you want to be thoughtful about kind of the path structure. But let's say database name, is here. In the serverless world, this is like a Dynamo table name, something like that. But let's just say in this case, this is going to be sfdemo, 10. Right? So we went ahead and just saved that change. Now, unlike an environmental variable where I'd have to go change all these functions, if I'm pulling that in my code, I don't have to do anything. It's immediately available. So let's go ahead and see how that could be pulled in. The other thing I had here just to show you was an API key. And if you notice, that's a secure string. So this is encrypted with KMS. So to go back here, I'll pull up the template of this project I have called Dynamic Parameters. And let's look at this, and you can see in here a few differences. So one, I have the folder fetch parameters. I can pull up my handler. But I do need access to permissions in AWS to be able to talk to that key to decrypt those secrets. And I need access to be able to get that parameter, right, from Systems Manager. So I have a policy in here that allows me to get parameters by path. And it's only allowing me to go to /environments. And I could use those variables here, like we were talking about, to say /dev, if this was deployed for dev. And then this is also backing an API gateway deployment with a get method. So to show this to you here, let me go into the code so you can see it as well. So here's the code of this function. This is a Node.js function. And what you can see here is basically, you can basically see the different responses here around how it's initialized, et cetera. And so one of the key things that's been broken out is this notion of initialization. So with initialization, things like, in this case, pulling the parameters, right, the database name, these kind of things, I don't need to do that every time someone fires that function. If I could do that just up front, I would save a lot of time and actually have my future invocations be a lot faster by doing that outside of the handler. So that's why I actually have this wrapped in a promise where I'm actually checking the status of this as a thing outside of the handler. And then ultimately, just like before, we're returning our location, but this time we're pulling in a parameters map. So if I go down here, this is what our initialization function is doing. It's actually going to get parameters by path. And the path I have is up here as a constant. It's anything in /environment/dev. So as you can see here, I have multiple parameters, but only 2 of them are of that path. The rest relate to a Twitter app. And then I'm pulling those in, and I'm just basically populating a map. And then I'm saying this is initialized, and that's it. So let's go ahead and take a look at this as well. So let's see, dynamic parameters. Let's see, SAM local. Local. Uh-oh. What's going on now? I think I might have just messed this guy up, actually. Let me see. I have another one where I was just messing with the same function over here. Uh-oh. Oh, I know. It looks like I have a dependency issue. What's this? Oh, address already in use. I actually have a socket issue. So it's trying to use port 3000. I have a terminal window that was using it, so I have a socket issue going on. And unfortunately, this is something with Cloud9 where if you close all your windows, it can be a little bit harder to get back to that. So what I'll do real quick is I'll actually just restart my dev environment to free up that connection rather than waste the time troubleshooting. And I'll show you some other stuff at the same time. Let me restart that. And you can, of course, go configure the ports and everything. But by default, that's just running on port 3000. And I said, Cloud9 is powered by an EC2 instance, or you can power it by SSH to your own hardware, wherever it may be, as long as it's public endpoint. So while that goes, let's go look at the Lambda console at this as well. So when we deploy a SAM template, what you'll notice here in the console is you have functions. And if you guys had looked at your last labs, I don't know how many of you dug into your functions. You would see, let me pick a function, actually. I'll go into one of my applications we're going to look at here. So for instance, this parameters application. One thing you'll see here is within the application, the simple notion for us is anything you deploy with SAM, we consider an application. So if you deploy it with the SAM template, it will show up under applications. If you don't, even if you use CloudFormation, well, CloudFormation actually does too, a stack. But if you deploy it any other way, we're just going to see the functions as they are. So when you deploy an application, you see the various resources here, and you can see all of their components. So I have a RESTful API, I have my endpoint, I have my function. And when I click into the function, this is where you can see, but on the left-hand side, what is your invocation source, your event sources. It could be more than one. So this is API Gateway. And then, as I mentioned, the policies around how it can get invoked. It's showing you effectively here what is that policy down here, right? And then on the right-hand side, it's showing you what is its execution policy. So what can it do? So this particular function can write its logs to CloudWatch. And we can go down and we can see, oh, it has the right to put log events. It has the ability to write to X-Ray, which you heard about earlier, which is a distributed tracing service. So this is very powerful to be able to figure out what's going on with the distributed environment, lots of components. And then it has the ability to reach out to Systems Manager. So without this IAM permission, we wouldn't be able to get our attributes pulled back. And so anyway, this is just a look at the Lambda function. To show you as well the application, we'll go into one here. And actually, you can see here this original SAM template. It's persisted with the application. You can even see the CloudFormation it became, which is much more verbose. But that's the SAM template. And then you have the ability to actually look in here at the different endpoints. So you can see we have a deployment, and we have our prod endpoint. So the code I was just showing you, we'll actually deploy in just a moment to pull up here. But you can go ahead and dig into the API as well and see everything. It's just all linked together with our application view. And this is a very simple API. We just have a get method right now. And then we have this notion that you learned this morning with API Gateway. Even if you're not using Lambda today, API Gateway can still offload a lot of the burdens of API management from you. Because you can integrate with any HTTP endpoint out there, containers, EC2, et cetera. You can also integrate with anything behind your VPC. So it doesn't have to be a public endpoint. And then another thing that's overlooked is what we call AWS Service Proxy. So this is the ability at high scale to have an API Gateway deployment talk to something like S3, talk to SQS, or Kinesis. So if all you're doing is getting orders and you want to be asynchronous, then you just want to queue them right away, right? And then you can have Lambda work through the queue. But there's no reason to have Lambda be in the middle to get to that queue. You save cost and you save latency by not doing that. So that's what this is. So to jump back, let's jump back over. And we'll have a look here. See how this is going. OK, we're reconnected. Let's see. So now, because I didn't have a rogue process stealing my port, I have this running again, right, on port 3000. And so I can go ahead and I can curl this just as before. And the code that I showed you earlier about actually pulling those parameters, here it is. Just for sake of showing you in plain text, I've decrypted the API key of 23456. And you have the database name, right, and it's all here. Now, if we go ahead and deploy this, let's go ahead and actually deploy this guy. I'll go back to here to deploy it. So there's two commands that are used to deploy. There's SAM package, which will take all of your code locally and zip it for you and take care of all that. Of course, you need to have the dependencies there first. We have a command called SAM build to actually build and install your dependencies as well. And so here, all I'm doing is I'm running SAM package. I have my template of my SAM template, and then it's going to basically rewrite that template with my new location in S3 and some minimal transformation. And my code just got uploaded that quickly. And then now I can basically go ahead and run SAM deploy. So let's see. Now that I have this all locally ready to go. So in this case, let's I'll go ahead and modify this. I just need to give it the name of the stack that we're updating. OK. And so this is going to go ahead and send that template to CloudFormation. It's going to transform it, and it's going to basically deploy it for us. And you can see, it's in this particular case, I had just done this deployment, and it says it's actually up to date. So if we go out there, we can go look in CloudFormation. And we can see this template, dynamic parameters. So within it, we have all the things we saw in the Lambda console. But the important thing here is we have a fully functional API now that we can hit at high scale. So when I go to hit this API, here it is, our parameter map, things I pulled in, right, that I only need to pull in initialization. And then if you notice, in this parameter map, we have a database name, right, sfdemo10. Well, if I go back over here, let's change our database name. Let's say it's 15 now. Now, if you remember, I had that intentionally outside of the handler, right? So even though I'm going to refresh this, this number will not probably change here because I'm likely going to be using the same sandbox where I've just initialized this to keep it out of the handler. And if you notice, it's still 10. But if I go back to SAM, to my local environment, and I want to run this command with the local API, in SAM, you'll always get your latest return. So if you notice, I got sfdemo15. Now, there are benefits of that. If with Lambda, you pay for the time it takes to run. It's 100 millisecond increments is metered. So actually, we've shaved 500 milliseconds or more off of that, just in this small example, for every future execution. And those are what we call warm starts. So just so you're aware. Anyway, so that is a look at dynamic parameters. So let's go back to other topics and a look at SAM as well. So we talked about how to go ahead and break down the application, right? All this duplicated code that you could have. Well, SAM has helped you, isolate that, deploy it, break it into chunks. But what else could you do? Well, we have something. If you look, if we take our core, modular business logic that's redundant and pull it out, and we take our helper functions and pull them out as well, then the handlers and very few other things are different between those other functions. So because of this kind of reusability that we're seeking with our code in general, we have the feature called Lambda Layers. And so this launched in November of 2018. This is new. So Lambda Layers allow you to basically upload a layer once and then reference that anywhere in any function. And this is a code. You can think of it similar to package managers like pip or npm or something like that. But what Lambda Layers allow you to do is they allow you to share any dependencies. Perhaps you have a governance team or a security team, and they want to inject some security agent, right, in every runtime or something like that. You have a question?
So when you said upload, where can you upload?
Sure, I'll actually show you a demo of that. But you can upload the layer direct to the Lambda service, and then you just reference it from your Lambda function. So it'll make more sense. I'll show you in the console real quick. But this allows you to iterate faster as developers and allow others to focus on their business logic, right? Additionally, if you have things like the AWS SDK, we do recommend as a best practice to not we bundle a version into the Lambda runtime, but we recommend you pull out the SDK and lock it into the version you need for your code at that time. That may be something you'd want to ship as a layer, as an example. So the way these work, just like a Lambda function, they go in a zip file. They're also immutable. And you can have up to 5 layers in a function. And the way they work is they have an order that they're applied. So the later order of them, just because it is a file system and they're being collapsed and expanded on the file system, files could overwrite earlier files. So you want to be thoughtful about the order of which you actually sequence your layers if you have multiple layers. And then they all get extracted to the /opt directory. And then fundamentally, all these layers, what's nice about them, though, is you upload the layer once, whatever amount of storage that is one time you've uploaded. Everything else is just the other code that was smaller, right? So your developer cycle now could get faster because you're uploading less code. even with something like SAM package, less code to transfer, faster to iterate, faster to see changes. And then, of course, if you're including dependencies and libraries, which most people would, then depending on the runtime, you want to put it in particular folders, because the goal would be that you could just require it in your code like a global module, and you don't have to know where it's installed, where it is. So for that to work perfectly, you need to be conscious of the paths and the folder structure where you actually put these packages, whether they're Ruby gems or pip packages or NPM modules. The appropriate folders are there. And then, as you asked about earlier, how can you use these? Right? Well, the first step is to actually create the layer. So you create the zip file, and then you create the logical construct of a layer, and then you reference the layer in your actual functions. So we'll look at this shortly as well. And then the final thing I wanted to mention, layers are the level of reuse at the Lambda layer, right? Or at the Lambda runtime components. But more broadly, you have functionality that may be common across many applications. So maybe reading a queue, right? Or having an API talk to a queue and then have Lambda read through the queue. Something like that. You could actually break out into different applications that can then be composed themselves into bigger applications. And so we have something out today called the Serverless Application Repository, which is available for your use. All it requires is a SAM template of your code. And the SAM template, as you saw, can be parameterized. So you can upload your template to this, and then you can have other applications reference your template. So it can be private for your own account. You can choose to share it with other explicitly named accounts, or you can make it public for the world. So today we have hundreds of these that are public out there right now that you could consume for your regular use. And the nice thing, when you want to go find something that does a particular thing, this is an example of like basic auth for API gateway. We have an application that you can just drop in and parameterize and hook into your app very easily. Similar for other things like processing tweets or sentiment analysis from Twitter. I have an example of that I'll try and show you. So the way these work is you have your SAM template, and it references another application is inside the template itself. So effectively what happens, because CloudFormation runs, is it's a nested stack. The thing that you've referenced becomes nested and separate, and then your top-level stack is your application. So that's what you see in your account that gets deployed, that you manage. This is an example of referencing an application here. So all you need is basically the ARN. If you haven't heard that before, that's Amazon resource name. That's a unique identifier for any resource in AWS. You need that, and then we have semantic versioning too. So like any good code module, you want to lock in the version of the application that you're using, just like our layers are also versioned immutably. So you can always have that ready. So for a final quick demo, let's first look at creating a layer. So let me go back to Cloud9. And let's go into the project. So in this particular project, dynamic parameters, I just want to show you here. For those that aren't familiar with Node, actually, I'll show it here. Those that aren't familiar with Node, you have the concept of NPM packages, right? Just like pip packages or something. And I only have 4 that are actually required here. But 2 in particular I would like to use in many different things. So the AWS SDK and our SDK for something called X-Ray, our tracing service. So those are both available. But if you look, because I have those there, what happens is, obviously those are built into the zip file. And when I go and actually try and look at this up in AWS, and I go to the Lambda console, then what I'll see is I'll see here my function code. It says, rather than seeing the in-browser IDE of my code and all that, it's more than a few megabytes big, so I can't see it in line. I can't actually modify it here. I'm forced to do everything in SAM in my own dev machine, then upload it, right? But if I were to pull out the bulk of that, which is just the AWS SDKs right now that I've embedded, then my code, the rest of the code would be much smaller, and I would just reference that layer. So I can do that here and make this reusable. So to go in, I actually created a little project here called AWS Node Layer. And all it is, this is a super simple project. All I do is I just have a package.json with the 2 dependencies. And then because I needed it to go in the proper path folder, I created the Node.js directory and the Node modules folder. And I just need to make sure the dependencies installed there. But all I did was run npm install. And all of these packages came from dependencies of these two packages that I had. So they're all there. But I don't have actual code to run. It's just libraries I want to use, right? So my SAM template for this is very, very basic. I just say I have a layer version. I'm going to call this, Lambda layer node. Let's actually, I'll just say it, node AWS SDKs. I've got my description. I do have to list for any layer my compatible runtimes. And then this is a really important feature too, which is retain policy. So if I were to go out and I delete my CloudFormation template, what happens to the layers that I already published? By saying retain, they will stick around. They don't get deleted unless I go explicitly delete them. So that's all it is there. And because it's a SAM template, I deploy it like anything else. So let's go back and let's see. Here we're going to package it. Oh, let me change folders. So it went ahead and got uploaded. And then we're also going to deploy it. So I'm going to change this now to I'm going to change this to node lambda layer. And so this will just take a moment here. What a change set is, by the way, if you haven't worked much with CloudFormation, you have the ability to just call something called update stack, right? But the problem with update stack is it would just do whatever it needed to make the before and the before become the after, right? So sometimes that may involve replacing or deleting things that you had created. What a change set does is it just allows you to see what's going to change if I go ahead and update the stack. So it allows you, if you want to stop and say, oh, it's going to delete these things and recreate these things just because I changed this SSH key, you can stop the process and intervene. So we always recommend using change sets whenever possible. So we've got that deployed. Now let's go out here to Lambda. And I'll go first to CloudFormation. And you'll see with SAM, here's our new deployment. And then if I go over to Lambda, in the Lambda console, let me actually go and refresh, and it's already there. And you can see I'm on version 1. I didn't specify a version, these auto number. And so here's our new layer. So I can see, node 8. And here's the important thing. I just need the version ARN of this layer. And I can go back here now. And I can go down under the template file. And all you have to do is add this particular layer's reference. Right, just being here. And so you can see, dynamic parameters. Same function as before. The only difference is I have the layers. The only other difference is if you notice out here, I don't have any AWS packages. I've pulled them all out. And my package JSON doesn't have my AWS SDKs at all anymore. Right? They're gone. But in my code itself, I change nothing. I just say require the AWS SDK, require AWS stuff. That's it. So now, with SAM, just as before, I can still start. Oh, let me get to the right folder. I can start an environment. I can go ahead and do any curl or anything else I want to do. And if I go back over here to the log, if you can see, this is all using Docker, right? So it says image was not found. It actually pulled down my layer from the Lambda service. It's building my image, mounting it locally into the Lambda virtual Docker environment. And then now I'm actually able to see my response. And my response just as before, just like it was, right? But now I have that reusable. And the other benefit, too, if I go back into my functions, then I can see, let me go to applications. Same function as before. See if this pulls it up. Oh, sorry, wrong thing. Here's what I wanted. So just like we were in that IDE of the Lambda function, we couldn't see any of the code. Well, now, because my package is so much smaller, I can actually edit my code in line. Though I recommend, for production things, don't just use the console editor. Better to use source control and SAM and other tools. But now I'm able to actually edit in line. So that's a look at layers. I think between that and SAR, and just a final thing I'll show you for SAR, quick app that I thought was a neat one out in SAR. I don't know if any of you have ever wanted to do some sentiment analysis from Twitter, but it's kind of interesting to see what the world thinks about each day, right? Obviously, the news cycles follow it, but without having to do any work except register a Twitter developer account. This is just one example of a SAR app, but this literally takes Lambda on a polling schedule. It defaults to once a minute. It goes out to Twitter's APIs. You don't have to know anything about Twitter's APIs. And it checks points, reading the streams, basically, of all the tweets that come through that match your filters that you want to get. And then as things match your filters, it invokes your function. So to make that possible, and to make that in my application, I created another application here called tweet processing. And all I had to do to pull that in was just actually reference the application. And I just copied this from their SAR. We have a button that actually generates everything here that I copied. I just literally copied this. I said tweet source. Here's the application ID. I want version 2. And it needed 2 parameters. It needed to know my search text, so I was searching for serverless. And it wanted to know what function do I need to send the tweets to. That's it. That's all I needed to have to basically go to Twitter and get that kind of value. And then now my actual function can do whatever I need it to do. In this case, though, I actually just deployed this. So we can go look at it. And we can see tweet processing. It's my application. And within tweet processing, I have my function. So let's go into that. And then this is the function that's getting the tweets now. That's my own function I control. And so we can see here, if I go into the logs, all I'm doing for now is just writing it to the logs. But we can see there's always what's going on right now. Learn how to use Azure functions. Well, we don't want you don't need to know much about that. Tips and tricks. This was a Microsoft treat, apparently. And I could go through them all. This is actually this is Twitter's official API spec here showing up. But that's all it takes. And now if I wanted to manipulate this, transform that data, send it to some other stream, DynamoDB, just a few lines of code is all it takes in a SAM template. So with that, just take 1 or 2 questions, and then we'll cut over to the workshop. No, you can actually, you can reference, even in the console, when you go to upload the zip file and everything, you can certainly hook up the functions as well. So last question, since we need someone else on the live feed. Anyone else? OK. Well, key takeaways. Check out SAM. You'll be seeing it in later today in environmental variables and all of this to get your applications to production. And here's our serverless page for reference. Thanks, everyone, for your time.